So we're going to do some notes on a continuation kind of over the stuff that we were working on before. Before we were solving quadratic functions and equations and same thing. But now we're going to be solving all types of functions. And that means the highest exponent could be 3, 4, 5, 6, 7. We're going to start a little process like that. I don't have any written out notes, so there's going to be stuff that I may say that you deem is important and that you need to write down. As I move into some of these topics that I did not get a chance to or cover in Algebra 2, I don't have the written forms that, in all honesty, I'm not sure that we were using anyway. So this is more about making sure you listen and pay attention, and if there's questions, you jot them down, and I'm going to work through examples as I explain what's going on. Okay, so my instructions here are to find all zeros given a 0. And what that really means is, in this particular problem, here's my function here. That's supposed to be like a semicolon or something. And this is the 0. They give me 1, 0. Now, really, let's understand first what I mean by finding the zeros. So, what I've done is, in my graphing calculator, I put this function here. X cubed. Notice how I had to do the caret button, which is this button right here. Anything over 2 exponent, you need to use that. Anyway, that means x cubed minus 2x squared. And I just put the whole function in. And then I hit graph. So what we're looking at is the picture. It's not zoomed out all the way. But this is what this would look like. This function would look like as a graph if we had to graph it. And so remember, a 0 or a solution or x-intercept or a root, all these are referring to the same concept. What concept is that? That's where your function crosses the x-axis. And so they told us that 2 is 1 already. So let's look at the graph. 1, 2. Does it cross at 2 here? Yes, it does. What they want us to do is find these other 2, assuming that we didn't have the graphing calculator. And so we want to find every single place where this crosses the x-axis, but we're not going to use the graphing calculator. I just wanted to show you what zeros were. What are we looking for? Anytime you see zeros, roots, solutions, or x-intercepts. Okay? And so if I give you one, this is going to be the procedure. All right. So it's going to bring back some old stuff that we've talked about. If I give you one and it looks like this, if I give you a 0 and it looks like this, I'm going to take that and set up this. This should look familiar to you. And I'm going to say 1, -2, -9, and 18. What am I doing? I'm setting up synthetic division here. I'm going to set up synthetic division to see what I get whenever I put 2 in. Notice I didn't change the sign of 2. It's x equals 2. Now, if they would have gave me the 0 like this, then I would have set it equal to 0, and then I would have used x equals 2. But they didn't give me that. They gave me this, and so whenever it's given to you like that, you stick it straight into the box. Remember the process. You bring the first one down. Whatever's down here, you multiply by the box. So 1 times 2 is 2. That's 0. 0 times 2 is 0, -9. -9 times 2 is -18. Now, if it's a 0, you should get a 0 at the end for the remainder. That should be right. If you put a number in and they told you it was a 0 and you don't get 0 at the end, you did something wrong. All right? Now, remember how to write your answer. This is important. If it was an x cubed, now it's going to be x squared minus 9, because that is 0x. And so that's how that would factor. So far, what we could say is this would factor into this. How do I know that? Because if they give me this, if I go ahead and subtract 2 and put it back over there, I will get x minus 2 equals 0. And so that's what I put here. The factors of this is this so far. But remember, I'm trying to find all the zeros. And I already know that x equals 2 is a 0. So what am I going to do? I'm going to take x squared minus 9, this other factor, because I already know what that one equals, okay? I'm going to take this other factor, set it equal to 0, and I'm going to solve. Which way am I going to solve? It doesn't matter. I know that this thing factors x plus 3, x minus 3. And so that would be x equals 3 and x equals negative 3. So if they already gave me 2, then x equals 3 and negative 3. Let's see if that's true according to the graphing calculator. Here's 2, the one that they gave me. Here's 3, the one I just found, and here's 1, 2, negative 3. So what we've done is just proven that the graphing calculator was correct. Again, let me explain what just happened here if you don't understand. What I did was I was given a 0, a root, an answer to this problem, and I used synthetic division so I can break it down even further. Once my power got to a 2, then I know what to do because we've been solving quadratic equations for the past week and a half or 2 weeks or longer. So if we can get the powers down to x squared, then we can use the quadratic formula, we can factor, we can complete the square or use square roots. Okay? Now, I'd like to show you something real quick. If I go back to this problem and I put 0 in for y, that's the same thing as y, by the way, just in case y'all not sure, didn't know. Let me rewrite this problem. You know what I see? I see 4 terms. Whenever you see 4 terms, you know what I think? I think about grouping. Okay, so what you just don't know happened is a mess up. And through the art of technology, we're going to correct that mistake right there that just happened, okay? So we're going to go off of this page so you don't see what I did that was wrong. In all actuality, what I did is I just wrote the problem down wrong. And so I started trying to work it, trying to show you what I was going to show you, and I messed up. I left off the 2 for that. But anyway, and look here. I made that a 2, and that should be a 3. I was about to do it again. Anyway, what I was about to say is that whenever you see 4 terms, I'm thinking of factoring by grouping, okay? And if I group those first 2, and again, that's a cube, because I'm looking at this original function here, that original problem up here. If I factor out my greatest common factor here, I got x squared on the outside, and that's going to be x minus 2. And then if I factor out the greatest common factor here, it's going to be a negative 9, and that's going to be x minus 2. And so the way this works is you get x minus 2, because those are gone, and then what you have left over is x squared minus 9. Alright, now look at that. Isn't that the same thing we had earlier? If it's set equal to 0, then this factors in x plus 3, x minus 3, and that's still x minus 2. And so you get all the same. You get x equals 2 and 3 and negative 3 as your solutions. What I'm showing you is if you use all the tools that I've been teaching you so far this year, there's potentially 1 or 2, 3, 4 maybe options that we can go to solve a problem here. Alright, because everything that we've done in this is something that we've done before. Alright, let's try this one. Notice I didn't give you x equals 6. I didn't say that, but it's just given to you like that. And so whenever it's like that, you just use the same number. What are you talking about, Freeman? Well, I need to find the zeros here. And I'm not going to show you the graphing calculator. Let's see if we can figure it out ourselves. First thing I'm going to do is synthetic division, making sure this is written in descending order. So I'll use 5, negative 27, negative 17, and negative 6. I bring the 5 down. 6 times 5 is 30. That makes a 3. That's 18. That makes a 1. That's a 6 and a 0. Remember, you should get a 0 here. If they give you a 0 and you don't get a 0, then you did something wrong. Alright, rewriting this, I get 5x squared plus 3x plus 1. And that's my new polynomial. I'm still trying to find all the zeros. Okay, why do I do synthetic division? Now it's written as a quadratic equation. I could look to factor this if it factored, or I could look to do the quadratic formula. I'm not sure that this factors So I'm gonna just jump straight into the quadratic formula. Why? Because the power here is 2. I know how to solve these when they look like this. See, you have to know all the little stuff that we've talked about, and you got to be able to apply it appropriately because it comes up. Everything about math you don't have the opportunity to forget because you'll use it again. So what am I doing? I'm substituting into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so this will be 9 minus, what is that, 20? All right. So we get x equals negative 3 plus or minus the square root of negative 11 over 10. And that's the same thing as negative 3 plus or minus I radical 11 over 10. We don't keep that negative there. And so that's what x equals. Since that's imaginary, what does that mean? I have two different answers here, but it's imaginary. So what does this mean? It means that 6 is the only solution or 0 or root that I have. Let's go to the graphing calculator and see if that's true. Let's prove that. Let's turn it on first. And I'll put 5x cubed minus 27x minus 17x minus 6. Okay, I know it was off, so I can read it. 5x cubed minus 27x minus 17x minus 6 is the function. And so I hit graph. Weird. Super weird. But I didn't put this in right. Let us go back and check. X cubed minus 27x squared. Ha ha. Yep. Made a mistake in that should be to the second power. I'm going to delete that. Alright, let's go to the graph again. Okay, so we got 1, 2, 3, 4, 5, and see the only place it crosses is 6 right here. It's doing some funky looking thing, and I don't have the whole big thing so you can see. But notice that the only place it crosses the x-axis is at 6. These are imaginary, so the only one real solution it had was 6. Okay, so what have I done in today's notes? Well, we have taken a little step further and said, you know what, we can solve anything. I don't care what the biggest exponent is. But first, we need to bring it down to the second power because we know how to solve things to the second power. And so if I give you a 0, like 6, you can use synthetic division to bring it down to the second power, it being a polynomial. After you do that, you can use the quadratic formula, you can factor. There's several different things that you can do, if possible, complete the square or square roots that you can use to help you figure out and solve. This is the step 1. We will continue doing work like this and increase. Our exponents are going to get bigger. We're going to do 5, 6, 7, 8. It doesn't matter. But the general idea is keep working it, bringing it down using synthetic division or something else that we'll learn. And once you get to the second power, then we got all these tools. That's the idea. All right. And of course, we got this, but I don't want you to be dependent on this and you don't know what to do. All right. So I'm not bringing these out yet. And if you have one, I'm not going to allow you to use them over everybody else until we get to a point where I feel comfortable that it's okay to use them. All right, that's it.